Yeah, I start the recording. Share my screen. So, okay, this is the assignment, no? If I so the assignment is related with mainly unit impulse signal and also unit step signal, no? So both are in discrete domain. Both are discrete time signals. Okay. So I want to tell you first. No? Okay. So let me take my journal. Okay, I have seen that many of you have some student has you sent me the problem they have gotten. Okay, they have faced. I can see all of you, almost all the students are trying to go in standard method. Okay, using the function. Some function may be impulse train or something. Okay, so there are some function related with this unit impulse function and unit step function in Matlab. Okay, so if you want to run them, you have to download them to your Matlab software. Okay, so in your version maybe they are not come in default. Okay, so sometime when you are trying to run that function, it may be not working. Okay, so that is the first thing I want to tell you. So the second thing is that, okay, so I think so you can see that these are discrete signals. Okay, so discrete signal. So if we talk about this unit impulse function, okay, so if you think the unit impulse function, we will first take this signal, okay, unit impulse signal. Okay, so you know that in continuous domain, okay, if it is a continuous time signal, okay, actually it is completely defined by maths. No? It is completely defined by maths. We can't achieve such a practical impulse. Okay, so I think this is the definition, no, for unit for in continuous time. I am talking about the continuous time signal. Okay, don't get confused. Okay, so if you think the continuous time unit impulse, okay, so it is defined like this, no, 0 infinity. Here t is not equal to 0 and this t is equal to 0. So this is the definition of the continuous time unit impulse. Okay, continuous time unit impulse signal. Okay, so if we draw the signal, okay, if we draw the signal, it is like this, no, this is t. Okay, so now this is a continuous variable. Okay, this is continuous time variable. Okay, so this is the function. Okay, so this is the function. So you can see that there is a arrow toward the infinity. Okay, so this is the plus infinity of the y-axis, no? So you can see there is a arrow toward the infinity. Okay, what this mean? This mean that uh, this impulse is uh, running up to infinity. Okay, so it is a continuous time signal. Okay, so I think you already there are some two definition actually. Okay, so we define the unit impulse function in two ways. I hope you have learned this in your signal and system. Okay, so one is like this, within very small limits. Okay, if we integrate the delta t with respect to t, we will get 1. Okay, so what is this mean? What is this? So this is the area, no? So this is the area. So we know that if it is equal to 1, that means this area, the area of this unit impulse is nominalized to 1. Okay, so here the area is nominalized to 1. Okay, 1. So that means the area, this unit impulse area. Okay, so that is so if it is 1, we have to run it to the infinity. Okay, so if you get the square wave square, okay, if you get the square, if you integrate this from here, okay, to here, so you will get the area of this square. Okay, so now you are reducing this value, reducing this plus sigma and minus sigma up to 0. So you are limit this minus infinity to 0, and you limit this plus sigma to 0. Okay, so it will come to 0. But if you want to get the area in 1, you have to run this square up to infinity. Okay, so then you will get this area. Otherwise, there is no area. Area will be 0. Okay, so it is a mathematical concept. Okay, so sometimes we put here as 1. So if it is 1, if we put here 1, what you understand is here the point is not 1. Okay, this point is going to infinity. What is this 1 means? It is the area of this impulse. Okay, so normally this is for the continuous time signal. Okay, so this is not very much relevant to your question. Okay, but I think it is better to have idea. Okay, so if we put here 1, okay, so this 1 means it is not the value of this here. It is not the value of this y-axis. Okay, so what here the 1 denotes the area of this impulse, the area, this area. Okay, this area. Okay, this area. Okay, so this 1 denote the area of the function. Okay, so that is so you can see that it is very so this is defined in maths. Okay, so this is very so we have very difficult maths here, no? I think it is relevant to lateral entry or the both student, because that is the jump start to the Matlab actually. So there you have learned how to generate a sinusoidal signal and how to sample, how to get the sampled version. Okay, so I think it is relevant to both of you. Okay, because this assignment you have, both the student has to submit, no, lateral entry and the other full-time students both have to submit. Yeah, I'm going to discuss the assignment. Okay, so let me explain. These are some basic things. Okay, before going to the, still we didn't start the Matlab. Okay, so still we are discussing the signal. Okay, the property of this continuous time unit impulse signal. Okay, so I think another definition is there, that is minus infinity to plus infinity, 5t delta t, it is equal to 50. Okay, so these are the definitions for delta t function. Okay, I think you have to submit the graph and the code both. Okay, so you have to submit the code and graph, otherwise uh, there is no proof. You can just download the signal and you can just download the signal and submit, no? So you have to submit the code, both code and the graph. Okay, code and the graph, it is very essential. Actually that is a good question. Okay, so you have to submit the both graph and the code for the assignment. Okay, no need to submit the M file. Okay, Matlab N5, no need to submit. Okay, not code file, you can just copy the code. Okay, copy the code, then paste it in a Word document or something, then you can graph the graph, you can plot the graph, then you can use paint and cut paste, you can just paste it the Word document and just send us one Word document. Okay, you can convert it to PDF, no? After finishing you can convert it to PDF and send us. Okay, so what you have to do is uh, you have to write the Matlab code in Matlab, then you have to generate the plots. Okay, then just copy the Matlab code and paste it in document, maybe in Word. Okay, and just copy the image and it also paste in the Word document, then you can save it as a PDF and send both code and graph. Okay, so I think that way is easy for you and for us to mark. Okay, otherwise we have to go through every M files you are sending. Okay, clear? Is it clear? So your submission procedure is like that. Is it clear? So anyone has a problem, you can ask. Okay, so I think you are clear with that procedure. Okay, so we will continue. So this is the definition for the unit impulse signal. Please remember that this is for continuous time. This is for continuous time. So you can see there is very high mathematical concepts are there, no? Mathematical definitions are there. Okay, so this is very maths complication. Okay, so this has very complex maths here for the continuous time. So what about discrete time? Okay, so what I want to tell you is that if you want to generate this continuous time signal in Matlab, you have to use that function. Okay, you have to use that definitely function you have to use. Otherwise, you can't generate. It will generate some errors because this should go to the infinity. Okay, so you have to use, definitely you have to use the function, okay, related function to generate the continuous time in Matlab. Okay, so we will discuss this in another time if we have time. Okay, so let's go to the discrete time unit impulse. Okay, so this is discrete time unit impulse. Okay, so can anyone tell me what is the definition for the unit impulse in discrete time domain? What is the definition for the unit in discrete time unit impulse signal? What is the definition? What is the expression actually? So this is the definition or expression for the unit impulse function in continuous time. Okay, continuous time. And also you have a definition for shifted unit impulse function. No, you have a definition for shifted unit impulse function. It is like this. Okay, so it will be 0 infinity when t is not equal to k, but here t is equal to k. Okay, so it look like this. Okay, so this t and here k, so k is going to the infinity. So this arrow is very important in continuous time case. Okay, so this is delta t minus k. Okay, so this is the k. Okay, so this is the shifted unit impulse function in continuous time. Okay, so this is the expression for the unit impulse function, and this is the expression for the shifted unit impulse function. Okay, so what is the definition or what is the expression for the discrete time unit impulse signal? So you know that in discrete time we normally use delta n. Okay, so in shifted version we normally use delta n minus k. Okay, so you know that this n are sample, no, n this n are sample. So this n can be an integer from minus infinity to plus infinity. Okay, including 0. Okay, so it can be 0, 1, 2, up to infinity, minus 1, minus 2, up to minus infinity. This n is an integer value, plus or minus integer. Okay, integer. Okay, so can anyone tell? Can you remember? So if I write it in this way, so it is like this. Okay, so you know that it is 0. It is just like in a continuous time case, it is 0 when n is not equal to 0. Okay, and if n is equal to 0, what is the value here? What is the value? What is the value here? Please tell me. I think you have learned this in a theoretical class. No? Please tell me what is the value here. So this is very important actually. Because when you are, yeah. Yes, thank you. It is 1, no? It is 1. It is not infinity. Okay, it is not infinity. Okay, it is not infinity actually. Okay, it is just 1. Okay, so here it is 1. Here it is 1. Okay, so by looking at this definition, I think you can, actually this is not the definition, this is the expression. Okay, this is the expression, not definition. Okay, so what is the expression for the shifted unit impulse? It is 0 when n is not equal to k. It is 1 when n is equal to k. So it is just a number here, not the infinity. So what do you think this? Are there any high mathematical concept? Are there in any integration, derivation or something, differentiation or something? No. Okay, so you can, if you plot this, okay, so you will get, this is like this 1, this is delta n. Okay, and you will get again 1, this is delta n minus k. Okay, so it is at 1, sorry, it is at k. Okay, so this also 1. Okay, so that 1 means actually this value. Okay, the x-axis value 1. 1 means x-axis value. Okay, but here the one is not the x-axis value. Sorry, is it sorry, y-axis value. This one, sorry, here I have done a mistake. Okay, so this is y-axis. Okay, so if you put one here in discrete time, okay, that is actually this point. Okay, point of this y-axis. Okay, point of this y-axis, the value of this y-axis. Okay, but in continuous case, if you see the one is here, okay, that is not the point at the y-axis, that is not the value at y-axis, that is the area. Okay, so here this one is has a mathematical complication, but in a discrete case we don't have any mathematical complication, no? So what is this impulse actually? Okay, so if you have this idea, I think you can do all the question. Okay, if you think in simple way, you can do that, you can generate that any signal. Okay, so what is this actually? This is a point. Okay, so this is nothing but it is just a point. Okay, so that is unit impulse signal. Okay, so you can see that. Okay, so what you have to understand is that for the discrete time case, there is no any mathematical complication. There is no any mathematical complication. Okay, mathematical complication. There is a direct definition, no? There is a direct definition. Okay, so actually sometime I understand this continuous time is somewhat the mathematical analysis, mathematical modeling. Okay, okay, this is not completely correct. Okay, but I think like that, then it will easy to our work. Okay, so the unit impulse signal is somewhat practical situation, but it is not practical, it is not complete practical. Why? Because this time, this impulse duration should be zero. Impulse duration should be zero, the time duration. But practically we can't achieve zero duration pulse, no? Zero duration pulse. So practically we can't achieve an impulse. Okay, so we can have a duration for very small value, very near to zero, maybe in nanosecond, microsecond range. Okay, but we can't go it up to zero. Okay, but we can achieve nanosecond and microsecond pulse, but these are not impulse. Okay, but you know that these are not impulse, they are just pulse, they are just electrical or optical pulse, not impulse. Okay, so we can't practically achieve an impulse, but somewhat this is related with the practical things. When we are sampling, okay, when we are learning, when we are analyzing sampling, sometimes we get this discrete time impulse signal. Okay, so that is the idea you should have. Okay, so you know that using stem command, you can generate the discrete time signal. Okay, so here also you can use the stem directly. Okay, without going for any function. Okay, so let me see it. Okay, so this is the background you should have. Okay, so the next one, let's take the unit step function. Okay, so I hope in your assignment there is a unit step related things there, no? So I have opened the lab. Here it is here. So you can see that, yeah, unit step function. related questions are there. So I think now you have an idea, no, how to generate this. Now I think you may imagine, you can think of how to generate this. Okay. Okay. Let's anyway. Let's take a look at unit step function. Okay, that is UN. No, in discrete situation, discrete time unit step function. Okay, function. So one thing is that sorry, Rifki, I actually forgot to upload it. Today I will upload. Okay, today I will upload. Okay, okay, I will try. Okay, but don't focus too much on Matlab stuff, because for a final examination you will not get Matlab related question. Only for 1 or 2 assignment. Okay, you have to use the Matlab. Okay, so I think it is no need to go very thorough on this Matlab stuff. Okay, but it will important to your higher studies. Okay, so you can practice if you have time. Okay, so let's take I can't understand 3s and another exercise also. 2 assignments are there. Are there 2 assignments? Today also you have get the assignment. Okay, let's so only 1 assignment is still, no? Are there 2 assignments? What is the previous one? You have 1 assignment, as I can see. You means this one? So what is the activity here? You have to go through this. So anyway, you have to go through this. Actually, I still can't get you, Rifki. What is your problem? Can you just tell me? Can you switch on your microphone and tell me?
Hello, sir. There is already an assignment called a Matlab activity. Just down the video.
Yeah. In that video also you have some exercises?
No, not in the video. Just below the video side. I mean, can you see a link there? Matlab activity 1, discrete signal generation. There is one exercise. So that's a different exercise. I mean, what you show is not there. So what I'm asking you, is that a different one? Yeah, altogether there are 2 assignments, so only one have to do. That's what I'm asking.
That you means I open a wrong assignment?
Yeah, that's what. Yes, sir. Because already there is one PDF is there. That's a different from what you saw today. I can send you if you want. Yeah. So can you open the?
Yeah. Can you see my screen?
Yes, sir. Yeah. Yes.
Okay, I will open. So this is your LMS. Okay.
Yes.
So if I go to that one, okay.
That below the video, that one. Yeah.
This one, no?
Yes.
I have opened that one, no? Isn't it? I got that one, no? This one, no? This is the activity, no? Am I right, Rifki? Is this the assignment or not?
There may be a different link, sir, but I think it should be okay now.
Okay, can you send your assignment maybe for the lateral? You are a lateral entry student, no?
Yes, sir. Yes.
So maybe Dr. Udesh has sent another assignment for you sometime.
Okay, sir. I'll check, sir. I'll check one second.
Okay, so you can send me your assignment because I can't see it in the LMS. Okay, then I can do some thing related to your assignments also, your guys assignment. Okay, so now I will do this one. Okay, I will focus on this one because I don't same, no? Okay, thank you. Yeah. Okay, we will see. Okay. Actually, when this LMS page is being created, some exercise are added. Okay, that is not relevant to our subject, but some exercise are added. So those may be still there. Okay, I have deleted most of them. Okay, but some for one example, one mechanical quiz is there. No? Okay, so that quiz was there. No? That one also the not a relevant one. Okay, so I hope. Yeah. I also think like that. Yeah. Okay, so anyway, we will go through this. Okay. So let me quickly recap what is unit step function. Okay, so unit discrete time unit step function, you already know that it is the expression is like this. It is also 1 0. Okay, so here 1 is n greater than 0, no? Greater than or equal to 0, no? Yeah, so it is like this, no? Like this, no? So from 0 to infinity. Okay, so n is greater than 0. Okay, and 0, n is less than 0. Okay, so this is the unit step function. And if you think the unit is the shifted unit step signal, okay, so it is like this. It is 1 0 when n greater than or equal to k and n is less than k. Okay, so this is the expression for shifted unit impulse. Okay, so what you can see here. Okay, so you can see some impulse there. No, actually there are some impulse. Okay, so if you consider this unit step signal, there is a collection of unit impulse. No, there is a collection of unit impulse. Okay. Okay, so if I get like this, if I get the shifted unit step function, shifted unit impulse function, okay, this is unit step function. Okay, so I will tell this delta function. Okay, so unit impulse, another name for unit impulse function is a delta function. Okay, so I will call this as delta. Okay, otherwise I also get confused sometimes. Okay, so this is delta function and this is the unit step function. Okay, so this is the expression for the discrete time unit step function. Okay, so if I get the shifted delta function, so it is like this. No, okay, it is like this. So that means if I plot it, you will get the impulse like this. Okay, n minus k. Okay, so if I get delta n, okay, so here the impulse is here. No, so if I get delta n minus 1, the impulse is at 1, at 1. If I get delta n minus 2, the impulse is at 2, at 2, no? Okay. So you can see that if we get, so this is the summation, no? Collection, sum of the shifted unit impulse signal. So if I get the sum from k is equal to 0 up to infinity, okay, you will get unit step function. No? You will get the unit step function. If this k goes to infinity, you will get some shifted impulse like this up to infinity. Okay, so this one also very important because we are going to use this to plot our unit impulse. Okay, so you can just plot the unit step using this delta shifted delta function. Okay, using the impulse. Okay, so please note this one also. Okay, and also I think you may have learned that any signal can be, let's say, the any discrete signal, any continuous signal xt. So it can be converted to discrete signal. Okay, discrete signal using here t is from minus infinity to plus infinity, xt delta in minus t. But here t, let's take, I think it is better to take t because t is normally we referred as a continuous signal. Okay, continuous variable. Okay, but here it is not a continuous variable. Let's take k infinity to plus infinity xk delta n minus k. Okay, so I think these things are the basic thing you should understand. Okay, so so I think now we can move to our MATLAB question. Okay, MATLAB question. Okay. So let me go to the MATLAB screen. Okay, I will get new page to write my script. Okay, so as usual, I will use this two command. Okay, use this two command to clear the workspace variable. If there is some variable in workspace, I need to clear them. Okay, so I use this command to command. Okay, so now if you want to generate the impulse, okay, one impulse, do you want to go through it to many function? Actually, no. What is the impulse in discrete? Domain, it is just a value. Okay, that value is equal to 1. Okay, so let's take a d. Okay, so I denote my delta function with d. Okay, so it is d is equal to 1. Okay, so d is equal to 1 at which time? At which? At n is equal to 1, no? And n is equal to 0. Okay, so if I plot, that means if I use this system command, so you already know that this system we can use to plot discrete version. Okay, so this is the discrete time signal. So I am using the stem command. Okay, please keep remember that this is only for discrete time delta function. Okay, but for a continuous time you can't use this simply. Okay, you have to use some complex command and some function. Okay, to do that. Okay, so later we will try to do that, but here very easily you can generate. So this is the independent variable n, with the dependent variable is d. So if you plot n with respect to d, sorry, d with respect to n, you will get the impulse, no? So I will save this as assignment. Okay, assignment 1. So you can see one impulse is there, no? So this is a unit impulse for a discrete time version. Okay, so uh, if you want to draw a shifted unit impulse, okay, so what you have to do that in Matlab you can't give just a variable. Okay, you have to assign some value there. So if I want to say I want to draw delta n minus 1, delta n minus 1. So what you have to do? You have to do simply you can put here 1, no? So if you plot this, so here now impulse is here. So this is delta n minus 1, no? So likewise you can plot uh, any unit impulse. Okay, any unit impulse. Okay, so I think so let's go to the assignment again. So this is your assignment. So you can see that here we have some delta function, no, collection of delta function with some weight. Okay, so if you put weight for this delta function, that means it is just a multiplication. Okay, so here, so if I get okay, so I will get like this. Okay, so I have a signal. Okay, I have a signal like this xn. Okay, so it is a, so I have a sequence. Okay, so that sequence is like this: 3 delta n plus 4 delta n minus 3 plus 5 delta, maybe minus. Okay, if it is minus or plus, don't care. Okay, the same result you will get, n plus 2 or something. Okay, so I will have this kind of sequence. So if I look at the sequence, I just have here what I have. Okay, I have 3 here. Okay, that is for 0. Okay, and I have 4, and I have 4, that is at 3. Okay, so the sample is 3. Third sample I got 4. Okay, and the minus 2 sample I get 5. This is the minus 2 sample. Okay, so if I plot this signal, I will get like this. Okay, I will get like this. So this is the 3 at 0. Okay, so it is 3. Okay, I have one impulse like this, but it is 3 here. Okay, and minus 2 I have 5. Okay, minus 2 I have 5 like this. I have 5. Okay, and this is 0. Okay, and this is 5. Okay, this is 5, and at so the first sample is 0, 1, 2, these are 0. Okay, 3, 0, sorry, 3 at 3 it is 4, no? So here it is 4 like this. So this is my sequence, no? And also minus 1, 0, minus 1 also 0. So this is my sequence, no? Agreed? This is the signal. So can't you just plot this in Matlab? Okay, you no need to use high complexity, complex functions to plot this. Okay, you can simply plot this, no? So if you know this signal, okay, so I will tell how to. So so actually, for this type of question, you can define some variable for this value. Okay, for this value, you can define some variable. Okay, so let's say for this L variable is V1, and for this variable is V2, and for this variable is V3. Okay, then you can give a chance using input, no, using input statement to give some value to the V1 and V2 and V3. Then also you can generate this kind of signal. Okay, if you want to do it like this. Okay, but here no need to go like this. You can directly plot this. Okay, so if I plot this, okay, so I will tell it again. Okay, when I use the Matlab. Okay, so uh, here I will do like this. Okay, so actually here you have let's say here you have V1. I will put it as variable. Okay, so let's V1. Okay, okay, V1, and the next in, I think you have to draw it here, no? Okay, N1. Okay, so no, if we define like this, it will not fun. I hope. Okay, so what we can do is, okay, what we can do is here. Okay, it is better to separately plot this impulse. Okay, okay, I think that is the easy things. Okay, so let's take this is as N1. Okay, N1. Okay, so here here the weight, okay, weight is 3, no, weight is 5. Okay, let's say this V1 is -2, the weight is 5. Okay, so here also you can define the weight also. Okay, so let's take weight 1. Okay, let's take weight 1 this. Okay, so here you have weight 1. Okay, weight 1. Okay, so here you have N2, N2, it is 4. Let's take it is V2. Okay, and N3 as V3. So you have 3 function. Okay, so I define the shifted variable, shifted time here. Okay, like this. Okay, so here you have 3 impulse. So one impulse is like this. Okay, so another impulse I will put like this, W2, and B is equal to W3, so on. Okay, like this. Okay, okay, so let's say this is D1 and this is D2. I think if you use if you use only one variable, that will also be okay. Okay, but anyway I will put like this. Okay, so I have to draw this 3 variable, no? three signal. Okay, so I will, so you can use this using a for loop also. Okay, but still we are not doing the for loop. Okay, so actually you can use the for loop very easily. Okay, then you can generalize this to any function. Okay, so I want some time to think about that. Okay, but meanwhile you can think. Okay, so if we have time, we will try to do this using a for loop. Okay, so using a for loop, this can be achieved for any general case. Okay, okay, so if we have like this, okay, n1, n2, n3, okay, n3, d1, d2, d3, okay, like this. Okay, so so you can define this variable. No, you can ask to give the weight and the variable. So you can use how to use actually here you can use no input variable one, no, input variable one, like this. Okay, is it clear? Okay, so you can use like this, and you can use input, okay, variable like this. Okay, okay, so you can see that if I run this, okay, if I run this, okay, so let's put the value here, because otherwise we have to, I can't type all the things. Okay, so here let's give some value here, the appropriate value 3 and 4, I think, as I can remember. Okay, so this sorry, this is for 1 for 0. Okay, this is 1 for 0 and 1 for minus sorry, plus 4 or 3, no, plus 3. Okay, so here this is -1 variable, and this is 0 variable. At 0 it is weight is 3 or something, this is 3, and here it is 4. Okay, and this is 5, you know. So if I run this, okay, here we need to put the bracket. Okay. So we have to give the v1 variable. So what is the v1 variable? It is -2, no. So we can put -2. Okay, and then we can use we have to give the w1 variable. So what is the w1 variable? As I can remember, it is 5, no. Sorry, this should be 3. Okay, okay. Also I have to put the hold on here. Okay, otherwise not all in one. So v1 is as I can remember, it is -2. W1 is 5, you know. So this is the impulse, no? -2, 5, 0, 0, and 3, it is 4. Okay, so you can see that by giving the any appropriate value as an input variable, so you can define these also as an input variable. Okay, n2 and n3. Okay, that is the idea. Okay, And also you can define this D2 and D3 also as a input variable. Okay. So these are the weight. So here you have to put the weight, and here you have to put the shift, time shift. Okay. Time shifting value. Okay. Then you can generate such an impulse. Okay. Clear? So I think now you can do this one. Okay. Now you can do this one. Definitely you should be able to do this one. Okay. So so try to do with the for loop. Okay. So try to do with the for loop. Okay. Still we are not doing the for loop, but I think you can just you have the knowledge. Okay. You can just search the internet and find about the for loop, and just try to plot this using the for loop. Okay. So I just plot it in direct way, but this is not a good one. If you have many if you have a large sequence, okay, if you have a large sequence, so you have to repeat this again and again. Okay. But using a for loop, you can do it very easily. Okay. So you can so please remember that one is okay. Okay. So you can use a for loop. Okay. You can use a for loop for n so you have to find this value. Okay. You have to think and find this value. Okay. You can for n, let's say 1 to 5 or something, 1 to 6. Okay. So here also you have to sometime you have to check yeah. So I think you are talking about the previous one, no? Okay. So I will please give me a, so are you talking about the previous assignment, yesterday done assignment, the sampling stuff? Uh, 13. Yeah. This assignment first question. What is this assignment? N is equal to -52. Yeah, you have to consider. You can so you can, that means you have to plot the 0 there. Okay. So it is like this. Okay. So if I go to this one. Okay. So let me, you can't write. Okay. I copy. Control C, Control V. Okay. So here, okay. So what is this means? Okay. So if I plot this, okay, we have to get n from -5, -4, -3, -2, -1, 0, up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 40, up to 15. You have to get the n value up to 50. So when you plot this, so n plus 1, you will have 3. Okay. So that means in that plus mean you are shifting to this way, no? Okay. So here you have an impulse, one impulse. Okay. So it is 3. Okay. And in 0, you have another impulse. So it is 2. Okay. And n minus 1, you have -1. That means -3 means here. Minus means it is shifted to here. Yeah, you have to show the entire space. Okay. You have to show the entire space. Okay. So what to do to show the entire space? You can use that xlim. Can you remember last time we used xlim command, xlimit? So this is the x-axis. So you can use xlim command, minus 50 to 50. Okay. So here 2, and you can see that here in minus 3, that means it is shifted to here, it is minus 1. So this is minus 1. You can see here minus. Okay. So n is 7. Okay. That means here you have plus 5. So this is the sequence, but this you have zeros. Okay. And here also you have zeros. Okay. You have zeros. Okay. And here also you have zeros. Okay. So you have to plot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17. You have to put 70 impulse. Okay. 70 impulse. Out of this, 1, 2, 3, 4 have value, 4 have values, others are 0. Others are 0. Others 13 are 0. Okay. So I think you can use a for loop. Okay. Otherwise, you can use the same. If you are not comfortable with the for loop, okay, you can use this. You can use this one. Okay. So you can use actually here n1 to n15. Okay. All the value. Okay. You can define all the n value here. Then you can define all the weighted here, and you can plot all the signal. So this will be very lengthy. Okay. But you have to repeat this command again and again. Okay. You can write this. Okay. But if you use a for loop, maybe you can do it very small range, but you have to think. Okay. How you define the for loop and how you put some condition. Okay. Because for some condition, you have to put 0, and if you input the weight, you have to put that weight. Okay. Did you get it? Yeah, you have to show that 0. Okay. So you can show that 0. Okay. For example, if I add here another one. Okay. For example, if I let's take this is 0. If I put here 0, if I plot this, E1, let's take minus 2, W15 or something. So you can see 0 here. Okay. So you have to plot this 0 also. Okay. You can do this. Actually, it is not wrong. Okay. So we no need to, in practical manner, we no need to show that zeros. Okay. But here you are asked to draw the graph from -5 to 15. So this 0, if you know, actually this 0 no need to mark. Okay. This 0 no need to mark actually. Okay. That 0 means there is no value. Okay. This 0 no need to mark, but you have to put up to here. Okay. This limit you have to put. Okay. But why this marking 0 is important? If say you are repeating this. Okay. Please understand the things. Okay. So let's have let's say I have a impulse like this. Okay. Impulse train like this. So okay. Here it is, let's say this is -2, -1, it is 0. Okay. And this is 0, it is about another value is there. This is example. Okay. 1, 2, 3. Okay. So I have 1 here, 1 here, and this is 0. Okay. So if you have this only this graph, okay, this graph, it is okay if you mark the 0 value for this or this. If you mark or not, the boths are okay. But say that this is repeating. You are repeating. This is a periodic impulse. Okay, then you have to repeat this. Okay, so if you repeat this again here, okay, again here you have this pulse, okay, and here you have minus, and here you have this impulse, okay, and next you have this one, and next you have this one, and here you have 0, okay. Then also again this is repeating, okay. So this time it is better to put mark the 0 also, okay. Otherwise when you see it you will get confused, okay. So normally, for example, can you understand what I'm talking? Okay. So normally 0 has not 0, the 0 doesn't have a value, okay. So if you mark or not the 0, it is okay. But if it is repeating signal, marking 0, okay, marking 0 is somewhat important because you can identify the period correctly, okay. Otherwise you can't identify the period. You can identify, but it is somewhat hard, okay. If you mark the 0 value also, it will be easy, okay. But I think for this question, okay, so Dr. Udesh asked to put the limit up to 15 to minus 50 to 50. That means this sequence is running from minus 5 to plus 50, okay. So that is why I say you better to mark the zeros there. Marking the 0 is not a big issue, okay. So what you have to do is you have to put the weight to 0, okay. For that point, for that time point, sample point, the what you have to do is you can put that relevant weight to the 0. Then you will get the 0. Then you can mark the 0 also, okay. Understand? Any clarification? So look, here you have a 0. So if you mark the 0 here, I think it is better relevant to that question, okay. But if you mark or not, it is not a wrong, okay. The graph is not wrong actually. Graph is okay, but for the question, it is better to mark the 0. That is what I want to tell. Is it okay? Do you have any issue? Okay. Okay, thank you. So, okay. So we will move to next one. I think okay, let's take this kind of one. Okay, let's see this kind of one. Okay, so you can see that. Okay, so if I draw this, okay, so one thing, so first I will draw, I think you can draw this, okay. So can you take 5 minutes and try to draw this signal by yourself, okay. Try to draw this, okay. First you can ignore this one, okay. You can ignore this weight, okay. So there is a exponential function, okay. So ignore that one and try to draw this. Take a 5 minutes. I think we have a time up to 15:45, so I hope we have enough time. So can you please take 5 minutes and try to draw the signal xn. Anjani, Anjani, මේ ෆෝන් එකෙන් මේ අර මගේ මේකට ලොග් වෙන්නකො මේ සුරවීරසගේ මේකට ලෙච් එකට මේ සුරවීරසගේ ලෙච් එකට ලොග් වෙන්න.
Refer to work that can be done to further improve the research undertaken by you. Right? Okay. Of course, I mean, I will not talk about application now because it's another thing, right? And also, it is not part of the syllabus.
Hello, okay, so we will so I hope you draw it. Okay, please say. Hello. Okay, I'm sorry. Okay, so let's try to do this. Okay, so you can see that here. First, let's try to draw a signal like this. Okay, let's try to draw a signal like this. So we have let's say we have some impulse. Okay, up to here, maybe up to 5 or 6. Okay, we have some impulse. Okay, so this is one. Okay, so we have impulse without any weight. The weight is 1. Okay, so like this. So how to plot this kind of impulse using the Matlab? So I think you can use your common common sense to draw the signal. Okay, so first is you have to define the n. No, so let's say that n from minus 10 sorry, minus 2 to so this n is a sample, so these are the integers, so you have to take one increment. Okay, you can't use any decimal increment. Okay, you have to use the complete step. Okay, otherwise it will not the n should be the sample number. Okay, so it should be a minus or plus integer. Okay, let's say we want to plot it -2 to 3 or something. Okay, so I have, so this is my n. Okay, so already you know that this is the array. Okay, this is the array. Okay, so if I run this, okay, so you have array, so these are your endpoints. Okay, now you need to put ones. Okay, so you need to put ones here. Okay, -2, -1, 0, and 1, 2, 3, 4. So you are going to draw the impulse, no? So here -2, -1, 0, 1, 2, up to 5, or up to 5 I take, no? So you will get this kind of impulse. Okay. So what you have to do is you can just use your delta function d as n, no? D as n. Okay. So I think this will be okay. Okay. So let's take stem n plus d. Okay. So if I plot this, I think we can get the impulse, no? The problem is that, yeah, sorry, because if I directly equal d to n, so this the d he calculate, put this n value, no? He put the n value instead of this n, and he calculate the d. So for the d also we will get the same value. Okay, so that is the problem. So we can't do like this. Okay, so it should be 1. Okay, 1, but you have to define 1. So you can't plot this. Okay, because so you will have only d value here. Okay, so it will give you a error message. The arrays are not in same dimension. Okay, so the arrays are not in same value. Okay, because this d has, this should d should be 1, 2, 3, 4, 5, 6, 1. Okay, can you remember? Can you understand? Okay. So here 1, 1, 1. The d should have 1, 1, 1, 1. Okay, and n have -2, -1, 0, 1, 2, like this. Okay, so you have the same value, same number of value here, same number of ones here. Okay, so yeah, so I think you can use. Okay, there is a, so we can so in Matlab. Okay, sometimes we can we have to generate empty array. Okay, we have to generate empty arrays. Okay, so in Matlab, if you write like this, if you type like this, okay, so it will generate the empty array. Okay, so you can put the dimension here within as I can remember, square bracket. Okay, so you can search this. Okay, how to create the empty array in Matlab. Okay, so it is very simple, you can get it. Okay, and sometime we have to, we can generate the array with all values are 0. Okay, and we can generate the array with all values are 1. Okay, like this. Okay, for that one we can use ones and zeros command. Okay, zeros command like this. Okay. So here also I hope we can use ones because we need one. Okay, for this array we need one. Okay, so I can't remember the syntax. Okay, so I will go my normal way. Okay, so I type here once in Matlab or something. I think it will give, yeah, once in Matlab. So you can see here the x1s. So this is the statement. Okay, so you can give the size here directly. Okay, so you can, so you see here you can see some example also, no? Okay, yeah, so we need to define this type of two-dimension array. Okay, so I will use this. Okay, so I just copy and paste it here. Okay. So I no need to this string part. Okay, so I delete it. Okay, okay, so here you have to count the length. Okay, you have to count the length. So 1, 2, 3, 4, 5, 6. So if you put 6, it is okay here. Okay, but you can count the length of this array. Actually, you can count the length of this array. There is a command for that. As I can remember, it is length. Okay, length. So let's take length. Yeah, this one on length. Yeah, length x. Okay, so if you get the, so this is x is the, this is the array. So if you put, so there is a array called x. So if x has 5 element, length x means 5. If you have, if x has a 10 element, length x is 10. Okay, so you can use this command. You can use this statement. Okay, so I will use it because rather than counting, I can use. Okay, because sometime when you are running the program, this length can be changed. Okay, so sometime, but here it is not changing, but sometime it is changed. So you can use that command, that is statement. So here length, it should be n, no? Length n. Okay. So I think this is okay. I think now it should be okay. Let's run. Not valid target column 5. Okay. So you can see that if I right click, if I click here, okay. If I click here, so we can see the corresponding bracket for this one. Okay, so this is the corresponding bracket to this one. Okay, so if I click here, I can see the corresponding bracket to here. Okay, so here also I think there is a only to this one. Okay, so this is enough, no? So I think now it is okay. There is no any error, no? So this is one bracket. Okay, and this is another bracket. Okay, so I think it is okay now. So if we run this, yes, no? Okay, you will get the string. Sorry, you will get the pulse train, no? 111 pulse train. Okay, so if you want to generate a unit step function, okay, that means it is from 0 to, let's say, it is up to 10. Okay, it is up to 10. So if you write like this, if you type like this, so you will get the unit impulse. So this is a unit impulse, discrete time unit impulse function. No? Okay, you can't you can't plot it up to infinity. Okay, in in mathematics, okay, this impulse are going up to infinity, okay, but you can't draw it up to infinity. You have to get some constraint value here, limit value here, okay. So you can see that we can plot a unit step function like this, okay. So so now the d we have created, okay. So now if you want to add some so you can see now we have defined x, okay, we have defined a sequence that is delta n minus k, okay. This k can be any k can be any value. It may be minus infinity, and k up to any value, it may be plus infinity, okay. So we have plot this kind of collection of sequence, no, we have plot this kind of collection of sequence, okay, like this, okay. So this k value, so this k can be minus 5 to plus 5, k can be 0 to plus 10, anything, okay. So this k value you can directly put here, no, you can directly put in as n, okay, like this, then you will get the sequence. Is it clear? I hope it is clear. So I think now you can you can draw any unit step function, okay, any unit step function or any collection of sequence you can plot, okay, without a problem, okay. So if you have to put some weight here, if you have to put some weight here, and you can see that that weight is also depend on the n, no? That weight is also depend on the n. Let's say that here we have to put some exponential weight, okay, xk delta n minus k, sigma k is equal to infinity plus infinity. This kind of graph you need to draw, okay. So if I practically draw this, how it come? Let's say this is minus, okay. So how it come? So it will come. Let's if we assume it from 0 to 5, okay. From 0, this will be 1, okay. So you will get 1. From 1, it is e to the power minus 1. So it is less value than 1, okay. And when it is 2, it is e to the power minus 2. So you will get the value like this, okay, like this. So up to 5 you will get like this. So you will get the impulse like this, okay. Is it correct, or is it to other way? It is in this way, no, okay. So this is the e minus t, no. If it get the e plus t, it is like this, okay. Maybe I have changed this, I can't remember, okay. As I can remember, it is like this, no. This is reducing like this, and this is increasing, okay. So this is called exponentially decreasing. It is e to the power minus t, and this is called exponentially increasing. This is e to the power t, no, okay. So this exponentially increasing and discrete signal are related with capacitor charging and discharging, no? If you can remember, okay. So I think this graph is correct, okay. Anyway, we will check, okay. So we will plot this graph and we will check whether this is correct or not, okay. Okay, so you will get this kind of graph, okay. So sometime it may be other way around, okay. Up to this, and it is going to like this, okay, and it is going to increase maybe, okay, or decrease, okay, from both, maybe this one or this one, okay. You will get, we will get. Understand? Are you confused? Are you with me? You have any problem? I am saying that I am not sure this is decreasing or increasing. Okay, that is what I am telling. Okay, it may be decreasing, exponentially decreasing, or it may be increasing. So it when we see it at the plot, okay, that is what I am telling. Okay. So what is the things you can do is, okay, so you can see that if you get this D and if you put that the weight, okay, so I will define it as another one. Let's say it is G, okay, so G or X, okay, so that is our signal. So this is X, okay, X is equal to X. This is X potential of X minus N, okay, minus N. So I think now it is okay. So if I put here stem with X, so I think we will get the graph. No issue. Let's try. So now we are going to plot from 0 to 10, okay? Correct. Yeah, no, that is correct, no? Like this, we will get like this. Okay, so these are not actually 0 value, okay? We will look like 0 because these points are very near to 0, okay? But if you can maximize the scale, you can see that these are not in. So you can see some very small line is there, no? No, yeah, maybe, yeah, line is there. Okay, so actually this point is not at 0. Okay, so some values are there. Okay, but this is okay. This plot is okay. Okay, so I think like this you can graph. You can plot any discrete value using a weight, and that weight is directly related with the sample point. Okay, like this. I think it is okay, no? So if you have any, so maybe minor issues can be there because I didn't do today morning, just around 12 o'clock, Dr. Udesh asked me to do the Matlab program, Matlab session. So I couldn't do any preparation, okay? So maybe some minor error can be happen, but generally it is okay, okay? So if I go to where is the no? So this, so I think so it is like this, no? We have used this kind of question. Okay, so here you have to the shifting values is 2. Okay, 2 by k, 2k. Okay, 2k. And k is from -5 to 5. Okay, so I think you have to do a little modification. I hope you can do it by yourself. Okay, please think. So so plot this again and again. Okay, so I think you can achieve this. Okay, so I hope other one also you can do it by yourself now. Okay, for example, okay, actually these are, if you draw this signal, you can see that these are also some collection of impulse. Finally we get the collection of impulse. Okay, so you can go through that method without any issue. Okay, and this one you can directly plot. Okay, yesterday we have learned to plot sinusoidal signal. So this is a composite signal. Okay, but what you have to do is you can define this n value minus 200 to 200, but I think this will not this much range is not clear in Matlab. Okay, so you can try. Okay, you can try. This may be not clear in Matlab. Okay, but you can try. Okay, if it is not clear, please reduce this n. Okay, if it is not clear in Matlab, you can reduce this n value, maybe from -50 to +50. Okay, like this. Okay, so I think this one also you can do. Okay, no any issue. Okay, so do you have any problem related with this? Do you have a confidence that you can do it by yourself? Oh, okay, so let's take one example. Okay, using the unit step function. Okay, so let's take. I will put only two signal. Okay, so we have a signal like this: xn equal to un minus un minus 10. Okay, let's say you have this kind of sequence. Okay, so if you draw this, okay, if you draw the un, you can see that you have some impulse. Okay, impulse up to 0, 1, 2, 3, so on up to 10. Okay, up to 10, and you will have another impulse up to infinity. Okay, and if you plot your un minus 1, un minus 10. Okay, so you will have up to -10, you will have 0. Okay, then from -10 you will get some impulse like this up to 0. Okay, so if you subtract this from this, if you subtract this, so you will get you can see that from here to here 0, here 1 is there, here 0, so this point will be 1 minus 0, 1 minus 0, 1 minus 0, 1 minus 0. So you can see that 0, 1, 2, 3, 4, 5 up to 10. Okay, it will be 1. Okay, like this. It will be 1. Actually, not up to 10, up to 9. It will be 1. Because at 10, this is 1, this is 1. When you subtract this 1, 1, you will get 0. So at 10, you will get 0. Okay, so infinity from here to here and here to here, you will get 1 minus 1, that is equal to 0. No? So you will get 0 impulse. There is no impulse up to infinity. Okay, so this is your signal. Okay. Your signal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is your impulse train. So right now we have discussed how to plot this now. How to plot this? So you have to define n from 0 to 9. Okay, then you can define the ones array to draw, to plot. Okay, then you can plot. Right now we have discussed. Okay, so if you have any weight, you can put the weight to the corresponding matrix, corresponding array. Okay, so I hope that part also you can do. Okay, so do you have any other problem? So I hope now you can do the assignment. You have enough knowledge to do the assignment. So let's wind up. Or if you have any question, you can ask. So actually, you can try to use for loops. Okay. I think it is not because I have to because sometimes the program may be wrong and we have to rectify it, and we have to we may be able to write the correct program. We can't write the correct program at once. Okay, so it will get some time consuming. Okay, so are you okay, or do you want any clarification from me, or can we wind up? So if you don't have any question, we will wind up. Okay, and try to plot this using. Okay, try to plot this using for graph, for loops, and you have to use the conditional. What is it called? That greater than or equal. These are conditional, something called no conditional statement or something. Okay. So sometimes you may have to use that one. In Matlab, you can directly plot. Okay. For example, you can go internet. Okay, you can go to the internet, and in the same way you can type for loop in Matlab. For loop in Matlab. Okay, so you will get the okay. So this is the way to use the for loop. Okay, and if you want to use the conditional statement. Okay, so inside this for loop you can put some conditional statement. Okay, so that one also you can find conditional statement in Matlab. Okay, so you can use this if condition. Okay, you can use this if condition. I think that is enough. Okay, if and else condition, if you use this if and end condition, it is okay. So if condition is like this. Okay, you can define any condition using if and else. Okay, so you have to this is also in one loop, so you have to put the end after if condition and end after any for loop. Okay, so if you write the for loop, if you write conditional statement in for loop, you will have to put this end command for a is conditional statement and also for the for loop. Okay, so anyway, I will try to write the program using the for loop, and I also will try if I have time. Okay, if I could complete it, I will send you the code. Okay, so meanwhile you can try. If you can't use the for loop, just use that straight way and try to complete the assignment. Okay, so okay, so shall we now? I think only 5 minutes is remaining. So shall we stop? Okay, then we will stop. Okay. Okay. Thank you for joining.